Hello, this is Evelyn Ramirez, and for my project 2, I decided to do temperature. These are the topics I will be talking about. Number 1 is experiments. Number 2, triangular shapes. 3, angles. 4, measurement. And 5, rounding. For video number 1, I decided to do experiments. In the first video, there is this guy and he's outside at like a flea market and he's asking people to see what would be colder, a book or a metal hard drive. Everyone assumes that the hard drive would be much colder because it's made out of metal, and metal is typically much colder. He actually tests this out and he sees what exactly the temperature is of both items, and they are exactly the same. Their temperature is the same. So then he does another small experiment to test out whether or how a cube will melt faster either on a plastic block or an aluminum block. He places 2 ice cubes on each of the blocks, and he asks everyone to try to guess on which block would the ice cube melt faster. Everyone thinks that it's going to be on the plastic block because the plastic block was warmer, and since the aluminum block was much colder, it wouldn't melt on there. But as it's seen, the ice cube melts much faster on the aluminum block, only because it is a thermal conductor, and plastic isn't a thermal conductor. So he bases his theory on thermal conductivity. For video number 2, I decided to do triangular shapes and angles. So everyone typically knows that little ice spikes form when you place, like when ice starts freezing, little ice spikes just come out. And I decided that my topic would be triangular shapes and angles because actually when an ice spike forms, it typically forms a 60-degree angle. It's just kind of how it forms, because it forms upwards, and then it also forms like a little triangular shape. As you can see right here, this looks like a triangle. All of these ice spikes look like triangles. So this is why I chose that. For video number 3, I decided to do measurements. So in this video, I learned all about the Celsius scale, and actually how Celsius himself didn't create it. It was a group of scientists that ended up creating the Celsius scale, but they just ended up giving him the name. So Celsius starts off with 0 being the freezing point and 100 being the boiling point of water, which is a pretty good measurement. That's how it's set, instead of how Fahrenheit is set to how the normal body temperature would normally be 98.6 Fahrenheit, and then 32 degrees in Fahrenheit would be the freezing point of water. I believe that the US and other little small countries are the only ones that actually use Fahrenheit, and everywhere else in the world, Celsius it's used. This is because it's just much easier to measure, and it is much clearer to see. Alright, last but not least, video number 4. For this video, we learned about David Fahrenheit, the creator of the Fahrenheit scale. So David Fahrenheit actually met up with Romer, an astronomer, and he ended up getting that scale from him at first, but Romer had it set to where 7.5 would be the freezing point and 22.5 would be a regular person's body temperature. Fahrenheit didn't really like this, so he ended up changing it a little bit, and he ended up rounding 7.5 all the way to 8. So that's where rounding comes in. That's how I understood the video, because he ended up rounding 7.5 all the way to 8 instead. Then finally, he multiplied all those numbers on his scale by 4, and that's how the Fahrenheit scale came to be, where now the freezing point is actually 32 degrees Fahrenheit, and the typical body temperature is 96 degrees in Fahrenheit. Alrighty, that was my video. I hope you liked it. Thank you.